Hi everyone, welcome to this webinar on the AWS Well-Architected Framework. My name is Rodney Lester. I'm the reliability pillar lead for the AWS Well-Architected Framework. I also lead the rest of the pillars in the development of their content. So to start with, let's talk about what the AWS Well-Architected Framework is. So it's really a list of best practices that we have learned over the course of the past 12 years or so in helping our customers deliver and operate their various applications on AWS. So it's really intended for developers, it's intended for architects, actually all the way up to finance people and business owners in order for them to learn what our best practices are in order to develop the best running applications for AWS. And the Well-Architected Framework is designed to have basically three aspects of it. So the first is that there are pillars. I previously introduced myself as the head of the reliability pillar, but we'll talk about what the pillars are later. There's some general design principles and design principles for each one of the pillars, and then there are questions around the pillars that you will answer. Why would you want to perform a well-architected review on something that you're either intending to deploy or something you already are operating? Well, there's really four main benefits. One is that we're trying to teach you how to think cloud natively. So we want you to take advantage of the features that the cloud gives you so that you can actually achieve the goals that you're trying to achieve by moving to the cloud. The second is really we want to give you a consistent approach to reviewing your architecture. There's lots of companies have a architecture review board or architectural standards. Those really need to be adapted for moving things to the cloud. So this will give you the ability to modify whatever existing functions you have in that to actually align with our best practices. The third thing it'll give you is you can actually uncover perhaps unidentified impacting decisions that you've made. So there's a number of fundamental best practices that are not intuitively obvious, and if you go through this, you'll discover if you've overcome one of those. And last, it gives you visibility into your risks. So just because you haven't implemented the best practice doesn't mean that you can't improve from what you've got. So you may have a good approach, but there are better approaches. Why would you want to apply the Well-Architected Framework? It basically comes down to some of the things that I've mentioned earlier, right? One of the main reasons people are moving to AWS and moving to the cloud in general is to build and deploy faster. You can't achieve that business agility if you're still using old style things that are slowing you down. We want to lower and mitigate risks, right? So the idea is that we'll identify what risks you have in your infrastructure and your application and give you methods for mitigating those risks. It'll allow you to make informed decisions about why you would want to do one thing over another. And last, we're going to teach you a bunch of AWS best practices. So here's a picture of Werner at last year's reInvent, where he talked about the AWS Well-Architected Framework. This framework really has been the culmination of years of experience. It was first released in 2012 and has been iterated on, although it's not fundamentally changed with the exception of one thing. 2 years ago, we added the operational excellence pillar. And the reason we added the operational excellence pillar is there's an operational aspect to every one of the other pillars. And we discovered that our customers were failing on the operational aspects. And so we have since brought together the best practices around operational excellence as well. The Well-Architected Framework is a mechanism for your cloud journey. So internally, we have a saying that intentions don't make differences where mechanisms do. So this is a mechanism for you to actually do something. You can learn our best practices, you can measure your architecture against our best practices, and you can then improve your architecture and your application based upon what you've learned. we really want you to understand the impact of your decisions. And so this framework gives you a consistent approach to reviewing all your architectures. You can understand the risk, you can learn the best practice. Once again, we'd like it to influence your future architectures and the future way you make decisions. And last, I talked about these foundational areas that are often overlooked. We really want you to consider those in all your future decisions. So, as within that picture with Werner, there are 5 pillars of the well-architected framework: operational excellence, security, reliability, performance efficiency, and cost optimization. We always start with operational excellence. As I said, there's an operational aspect to all the other pillars. And when you get into the actual design principles, you'll see those operational aspects, and the questions themselves actually make it fairly obvious as well. Security is, well, we'll talk about each one of the pillars as we go. Operational excellence, right? Like I said, why does it matter? It matters because if you look at the normal deployment lifetime, the actual architecture and development of an application is typically a very small percentage of the lifetime of the application. It's really much more around the operation of it and the gradual improvement of it. So, as I said, you actually have an aspect of operations in the security, the reliability, the performance, and cost optimization. So at AWS, security is our #1 priority, right? We always will prioritize security features and security needs over anything else. You should treat security with similar priority. It should be built into your entire system and really a concern of everyone during every part of the development, deployment, and operation of the application. Reliability, which is my pillar. Why does it matter? Well, availability matters, right? The fact of the matter is that no one wants their systems to be down. You want them to be up as much as possible. Now, in order to do that, there's lots of things you have to do. You have to be resilient to failure. You have to be able to automatically adjust to demand. More importantly, you have to be able to make changes, i.e. new deployments, config changes, patches, etc., without interrupting the operation of your application. One of the things to keep in mind is the disaster recovery piece of reliability. So most people are very highly concerned about loss of a data center or if you talk about AWS, a region. Perhaps overly concerned with it. And then they're way too lightly concerned with the more common failures, which are really software and operations. So it's much more likely that you'll suffer a logical disaster than a physical disaster, and you need to plan for that accordingly. Performance efficiency, well, no one likes to waste money on resources they're not actually using. So really, in order to get the most performant architecture, you need to know what to look for, how to instrument it, and how to iterate on it. So the performance efficiency pillar gives you instructions on how to do that. And last, cost optimization is something that is not commonly thought of in most IT shops. It's really because in the past you would do these enormous capital expense cycles. You would try to figure out exactly how much hardware you needed for the next, let's say, 3 to 5 years. You may have additional capital expense cycles to adjust that up over the course of the next 5 years. It never went down. But once you had that bought, it was a sunk cost. And so there was very little thought about saving money as you went. With the cloud, that changes completely. To use the analogy of the electricity model, you don't save money by leaving the lights on all the time. So a lot of the savings that comes from cloud computing is actually shutting off resources when you no longer need them. So there's other aspects to cost optimization, obviously. We have a cost explorer, there's different cost models. There's actually different types of ways of using instances like spot instances where you can save significant amounts of money on applications. So the cost optimization pillar is really around exploring all those options instead of just procuring a resource and then using it 24 hours a day for the rest of the life of the application. So now we're going to talk a little bit about the design principles. So we have a set of general design principles, and we have a set of pillar-specific design principles. These are the general design principles of the well-architected framework. You need to stop guessing your capacity needs. This goes along with what I said earlier about those enormous capital expense cycles. You were trying to guess your capacity needs. I've seen both ends of the spectrum of this. I worked on one application that our business and marketing thought for sure was going to be a runaway success, and we procured a whole bunch of hardware, and then it was not a success, and we hardly used it at all. And I've seen the opposite happen, where it was a minor feature. We didn't think it was going to be that popular. We had a few users asking for it, and we deployed it. Next thing you know, it was so popular, we were scrambling to get hardware in order to support the feature. So the nice thing about the cloud is you don't have to guess those capacity needs. Second thing is testing systems at production scale. This is also a common problem prior to the cloud. If you were able to test on hardware that was similar to your production environment, it was usually a scaled down version of it because it was expensive to have that hardware. With the cloud, you can procure exactly the same hardware and perform your tests on that hardware at that scale, and then simply let go of that hardware when you're done with it, and you don't pay for it any longer. The third thing is to automate to make architectural experimentation easier. You'll hear AWS employees constantly preach automation, automation, automation. But one of the benefits of automation is that you can actually build up this automation library that you can then share among your companies so that you can just start with someone else's automation and progress from there. It makes the experimentation much easier. The fourth is to allow for evolutionary architectures. It used to be in the past, if you wanted to experiment with some kind of new type of technology like queuing, streaming, you name it, the steps involved in doing that usually involved the capital expense for the hardware itself, and then going and negotiating with the vendor in order to get a license, an evaluation license, and then teaching yourself how to use it and deploying it. With the cloud, there's a lot of managed services that can give you at least an idea of how you might want to use one of these services, and you can experiment with it easily, and you haven't committed yourself to the hardware. You can, if the experiment doesn't work out, you can always just let it go and try something else. So this allows you to evolve your architecture over the course of time. The fifth principle here is to drive architectures through data. AWS has a bunch of default metrics that they give you on all their services. You can actually use that data not only to evaluate your current implementation, but as you experiment, you can actually do comparisons to evaluate whether you made the decision based upon data that is going the direction you want to go. The last design principle is to improve through game days. So we really believe in this process of conducting full-scale, including all the people that are involved, operational game days for various scenarios, security scenarios, reliability scenarios, you name it, business continuity scenarios. And the idea is that you can run this entire simulation at full scale with everyone who would normally be involved, and essentially conduct what's known as a fire drill and make sure everyone knows what they need to do during that time. The design principles for operational excellence are listed here, right? So the first one is to perform operations as code. So historically, people have been trained into doing things manually. The problem with manual operations is, even with a checklist, is that people skip steps. So if you automate your operations and perform it as code, you will find that you've got much more consistent application, and you actually have a history of what you used to do versus what you currently do. The second principle is to annotate your documentation. So annotated documentation is basically the ability to have code changes automatically reflected in your documentation, and the ability to actually invoke things from your documentation that are written in code. Third is a principle that comes from agile methods, making frequent small reversible changes. So the basic reason for this is that it's a small risk when you make a small change. It's a large risk when you make a large change. And if you have it reversible, and more importantly, automated reversible, the risk becomes very small. So you can make the deployment, you can automatically detect whether it improved your desired goals or not, and if it didn't, you can automatically reverse it and be back where you were before. The fourth principle is to refine your operations procedures frequently. A lot of times you set up operational procedures and they get literally set in stone. If they ever get modified, they get modified on the side, and it's through tribal knowledge that people know what works. That doesn't really scale in the long term, and it's error prone. So you really want to make sure you refine your operations frequently. You're doing a constant review. Are you doing the same? Are you actually improving or not? And make sure that you get that all documented in your code and your documentation. Fifth principle is to anticipate failure. This really has an aspect of reliability, of course, but that you want to be able to anticipate where failures will happen and how to recover from them. And the last thing is that you want to learn from all your operational failures. Regardless of how well you've anticipated failures, unexpected things can always happen. You need to have procedures, we call them playbooks, for figuring out what happened and how to fix it. The key thing is that you need to do a thorough root cause analysis on everything that happened, and then establish the changes that need to be done in order to correct, to ensure that you don't have that same problem again. These are the design principles for security. Security always starts with a strong identity foundation. You need to know who's accessing your systems, and more importantly, you need to designate what access, what authority they have to access what within your system. This goes both internal users and external users. Second is you want to enable traceability. You want to consume all the log files that get consumed and or get generated, and all the indications of who did what where. This allows you to diagnose when things happen. It also allows you to easily comply with regulations. The third principle is to apply security at all layers. In the classic data centers, we had what we call the eggshell model, where you had a hardened security on the outside, but if you got into the interior of say a network, you pretty much had access to anything. In the cloud, you can actually apply security at all layers and segregate access between those layers. The fourth is to automate all security best practices. So it was not uncommon for security teams to be tool users that use graphic user interfaces, as opposed to having automated responses to common incidents. With the cloud, you can actually automate a lot of your mitigations. The fifth principle is protect data in transit and rest. The cloud makes it very easy to encrypt data at rest. It's literally checkbox encryption on most of our storage, and we provided capabilities such as the Amazon Certificate Manager for being able to manage SSL certs, so that you can manage all your transit data encrypted as well. Sixth principle is to keep people away from data, right? People should not be able to access data unless they have the requirement to have it. It's super easy to actually keep the people away from data, because the way Amazon actually works, AWS actually works, is that you can, if you encrypt data with a KMS key, just because you have access to the data storage doesn't mean you can decrypt the data. You actually have to have access to the key as well. And the last principle is to prepare for security events. So goes along the lines with conducting game days. You really want to regularly exercise your security event response and to make sure that you know exactly what you want to do when an event happens. For reliability, there's 5 principles. You want to test your recovery procedures. This is a philosophy known as recovery-oriented computing. You want to minimize the number of recovery paths to ones that are well-known and well-exercised so that you don't have unexpected things happen during a recovery. The second thing you want to do is automatically recover from failure. So this goes along the lines of the statement I made where you want to automate, automate, automate. Your recovery should not be manual. You shouldn't have someone going into a system and manually repairing an execution. Auto-scaling groups can automatically detect if an instance is unhealthy, terminate the instance, and replace it with a healthy instance. You want to scale horizontally to increase your aggregate system availability. So this goes hand in hand with something that's known as stateless computing. You really want to keep your state, your persistent data, in minimum areas like databases. And every other one of your services you want to have as little state as possible so that you can use horizontal growth. It's a fundamental part of the equation for high availability that things in parallel actually increase your availability. And so you need to be able to scale horizontally to take advantage of that mathematical fact. The fourth, once again, is one of the fundamental design principles of cloud computing to begin with. Stop guessing capacity. You should automatically adapt to changes in demand. You need to scale up when you need to process more, and more importantly, you need to let go of resources when you no longer need them. And the last principle is to manage all your change in automation. So it does make a difference if you're deploying a new application, you're deploying a config change, you're patching your operating system. You want to do all this with automation. The design principles for performance efficiency, you want to democratize advanced technologies. So this means it makes it easy for you to get a hold of advanced technologies. For instance, flash disks were easily available in instances that you could experiment with and see what difference it would make in your applications, much easier than you could go out and buy one. But there's other aspects of this, which is really fundamental things like column and store databases and streaming technologies. You just are able to get a hold of technologies you couldn't get a hold of easily if you weren't using the cloud. The second is that you can go global in minutes. I want to be a little bit cautious about this. It doesn't mean that you can deploy a globally consistent application in seconds. It really means that if you need to deploy infrastructure close to your customers in another physical location, if you've templatized all your deployments, you just simply deploy in that location. You don't have to go out and procure a data center, sign agreements, ship hardware, etc. It makes it very easy to deploy into new physical locations. The third is to use serverless architectures. So serverless architectures enable you to basically cut down a lot on the operational management, but more importantly, you can really get some performance efficiency. So, for example, Lambda, if you've got things that just run occasionally, if you were running an instance that basically had to wake up and do a task for a few milliseconds every 5 minutes, you're wasting a lot of money by paying for it for all that entire 5 minutes. With Lambda, you can pay for just purely the 100 millisecond chunks that your service actually operates. The fourth is you can experiment more often. If an instance type comes out that has higher performance or promises higher performance for a cheaper price, you can actually go test that and see that if it actually delivers for your application and then move to it easily. The last design principle for performance efficiency is mechanical sympathy. This means using purpose-built services. So in the past, I talked about the experimentation part of things. It wasn't uncommon to use basically the technologies that you had in ways they weren't intended in order to accomplish goals. So a classic example of this is using databases as queues. So you basically would put entries in databases and then read them off on the other side, as opposed to using a purpose-built queue. With the cloud, you can actually use purpose-built services for doing what you want to do. So the principles for cost optimization are, once again, some of these are fundamentals of the cloud computing to begin with. One is to adopt a consumption model. So plan on managing your operational expense as opposed to planning what you're going to spend years in advance. You want to measure your overall efficiency. So you need to be constantly keeping track of how much you're spending on what you're spending. The third is to stop spending money on data center operations, right? So if you're a company that is not a internet service provider or hardware builder, it probably doesn't make sense that you've got people who are actually connecting up computers, routers, etc. You need to operate them, not actually build them. The fourth is to analyze and attribute expenditures. This goes back to measuring the overall efficiency. With the cloud, it is easy to tag your infrastructure, use those as cost allocation tags, and then track the expenditures. So you can actually track what you're spending where by business unit. This was very difficult to do in on-premises data centers, because even if you had the ability to track in some manner, it often would drift into each other's infrastructure, and then it was unclear as to who was using what. The last is to use managed services to reduce cost of ownership. So this goes back with the stop spending money on data center operations. If you can have a managed service where the underlying operating system and software is maintained for you and all you do is consume it as a service, you can actually get greater efficiencies. So a classic example of this is simply the relational database service. The operating system and the database engine itself will be kept up to date by Amazon. They used to have to worry about the hard problems of like, what's my data model, what's my query pattern, what are my long-running queries, how to optimize the actual performance of the database, but you don't have to worry about the fundamentals of actually deploying the database and patching the database. So how do you implement well-architected? We found that it's really key to identify a sponsor. You want someone in your company who is actually driving the desire to improve your architectures. You want to identify significant workloads that you're going to do an evaluation upon, a well-architected review. If you just start with small applications, your learnings won't be near as great. You really want to start with a fairly significant workload to evaluate the decisions you've made there. You really want to discuss the timeline and resources that you're going to address this with. Do you want to improve this within the next couple of months, the year, and make sure you have resources to actually implement the findings. And the fourth thing is you really need business context for the review. The business needs to be involved in understanding why these things are important. So you need to get your business owners involved to understand that you're going to be doing these reviews in order to make future improvements to enable the things that they really are wanting to get out of the cloud, i.e. typically cost savings and agility, as well as increased security and reliability. And last, you want a schedule that you can identify and track to. So, as I said, you want high-level business sponsorship. One of the key things when you're doing a well-architected review is you need to have the right people in the room. If you end up sending action items to go identify the answers to the questions, then you're not going to conduct the review in a short amount of time, and it could stall the review process. We want this to be a collaborative process, so you really need to make sure that you bring as much of a blameless atmosphere. It's not really important how or why certain decisions were made as much as it is identifying what you want to change. So once again, the preparation and data gathering before the review is a really key in order to keep the review short. We have partners and solutions architects that have refined this process to the point where they can conduct well-architected reviews in a matter of hours. But quite frankly, it's not uncommon for the first time of conducting a review for it to take you a day until you really understand the preparation and data gathering to do. Lastly, you should read the white paper. We have a white paper that discusses the entire process, has all the questions, has all the best practices. There's also additional pillar papers that are specific to each pillar. So if you conduct a well-architected review with a solutions architect or a partner, you'll get a report. This will give you areas that you were successful in meeting the best practices, areas that you need to improve in order to meet best practices, and then most importantly for most people is the ideas of areas that you have critical items identified. This will give you a prioritized list for remediation, right? You want to address the critical issues first and then work on the things that need to be improved. We give you a list of resources in the papers for best practices. We have training online. You can go to the well-architected page and directly link to the well-architected training. And then we have partners that have a competency in well-architected, and we have AWS professional services to help you do implementations. Here's an example of one of the questions. So this is for security, specifically around the incident response. How do you ensure that you have the appropriate incident response? So you'll see that it has a pillar area where it is in the incident response, the question text. It'll give you a context. So the context itself will give you a reason of why you want to ask this question. So putting this in place, the tools and access ahead of the security instance, then routinely practicing the incident response will make sure that the architecture is updated to accommodate timely investigation and recovery. So that's the reason why you want to ask the question. And then we'll give you a list of best practices. I'm not going to read them to you except for the titles. You want to pre-provision access, you want to pre-deploy the tools, you want to have non-production game days, and eventually you want to work or you can actually run these game days in your production systems. So for more information, once again, if you go to aws.amazon.com/well-architected/, we have a list of documents there and best practices as well as links to the training. So there's the overall framework paper. There's pillar-specific papers. We also have these papers that we call well-architected lenses. So there's lenses for HPC and serverless. If you're working on those applications, I highly recommend you read those too. There are actually additional questions to ask specifically around those aspects of your architecture. And then, of course, I said there's links to the free online training. So you can go through the free online training, which will be a little bit more in depth than this overview that I've given you in this webinar, and get some additional context around the well-architected framework. And with that, I'm ready to take questions.